Good morning, everyone, and welcome back to projectCD.Chronicles. An unusual starting point to talk about the Commodore 64. I have a OBS Studio open while I'm recording. What is the Telegram group, both for Ready and for Project CD Chronicles? I still have an active tab on Ready 64. And why not? I also have a part still open regarding Notepad. Now, as we all know, our systems are indeed multitasking, so they can perform multiple operations simultaneously. Obviously, the main program is what is defined as the scheduler. And here you can already see what's in this video. My question is, can the Commodore 64 run a multitasking system, thus being able to start multiple programs at once? Yes, of course. You can see it, and we will also see it running with this short assembly listing. But first, we need to do a brief recap on multitasking and some features of the 6502 and 6510 processor. I have already selected some tabs regarding the MOS 6502 processor and the MOS 6510 processor, which have some common peculiarities as well as differences. And let's start with this, which is the scheduler, particularly in what is our beloved Linux on the box. Obviously, we won't bring the Linux scheduler to the Commodore 64, but this allows us to better understand how it will function. In fact, the program that I wrote on the Commodore 64 to emulate what is multitasking. In fact, there won't be a real scheduler, but one could also implement process priority management. Why not? So let's start with the fact that a scheduler in a multitasking system is one of those components responsible for managing the CPU among the various running processes. The main goal of a scheduler is to optimize the use of resources, ensuring that all processes get a fair share of execution time. The scheduler has a standard operation. Indeed, so to speak, it involves process selection, thus deciding which process is sent for execution. And here we talk about priorities and other aspects regarding the scheduler. We can essentially divide it into two parts. A preemptive type, which can interrupt the execution of the program, and a non-preemptive type, which will not actually interrupt the execution of the program, but lets it run until the end. So without going into too much detail, let's say there are different scheduling algorithms. The one that comes to my mind is FCFS, first come, first serve, meaning the first to enter is the first to be served, where it essentially has a technique, the IFO, yet others could be the round robin and so on. And then what is the core, which you could see in the brief part where it was written. Scheduler, as far as the program is concerned, is the context of switching. That is, it is precisely the core where it is decided which process should be executed or not yet. As I told you earlier, this scheduler must ensure a bit of what is the fairness of performance. Independently, then, one could also increase the priority of the processes in the execution time, but all this is a higher level implementation for the Penguin enthusiasts. It must be said that the Penguin uses various schedulers that are applied for process management, particularly in what is the modern system. In Linux, among the most notable, we have the CFS, which is the completely fair scheduler. And let's say it is used precisely because it manages to balance fairness and efficiency more effectively, and therefore also resource utilization. But this takes us away from the whole convenient 64. Now let's go directly to what is the MOS and the MOS 6510. Well, we move from the 6502 to the 6510, which have a peculiarity in common. And we will then see here also in what is the pinout, but I saw that here on Wiki for the 6510, it is done better. Anyway, what do they have in common? Like all processors, we need to verify this, the non-maskable interrupt at the programming level. As for microprocessors, there are interrupts. We had already talked about it before. The rasters, there are several in the Commodore 64. Among these interrupts is a particular condition where the microprocessor interrupts the normal execution of a program to do other things, period, in the Commodore 64. And so regarding the 6502 and 6510 processors, there are essentially, in this case, two types of interrupts, those that are non-maskable, which must necessarily be executed by the machine, and other interrupts that are called maskable. Okay, there are two types. The first cannot be ignored and must be executed regardless. The second, through, so to speak, what is a switch even in software, we can say to ignore it. This is the substantial difference. Now we must think of an interrupt as the classic ringing of a phone. Generally, I have my cell phone, it rings. I interrupt the activity I'm doing, answer the phone, end the call, and continue to do the activities I am doing. Now, it is precisely through this interrupt where I get the ring, I take everything that is the state of the machine I save it, so mentally what I was doing, but what happens in this case in what is in modern systems. Before going back to writing my entire diary that I am doing here, the scheduler checks, but are you sure you don't have another task to do? Well then, from the phone call, for example, I go to print an email that I received after I printed the email. I practically return to the phone. And then I go back to writing the diary again. Essentially, this verification can be done exactly with our Commodore 64. And indeed, through what are maskable type interrupts, we can redirect. What is this little program that is the scheduler? So we can tell it, and we will soon see here to manage our running programs. We've seen this raster technique many times. We've seen how to enlarge sprites. We've seen it for countless other purposes. And essentially, I interrupt what are the interrupts with the 6, then I restore them. But in the meantime, this interrupt I was telling you about, I go to make a hook. So in fact, I go to tell it, here there are vectors 314 and 315. There are vectors to the normal interrupt routines, which is A31, which would normally execute A31, but I make a hook. So I make it jump to my routine, then to go and correctly execute what are the normal activities of the microprocessor. But what happens at this point? Here I have inserted what is a scheduler. And before continuing, let's review some more concepts of the 6502 and 6510. Then we will execute the program and return here. Anyway, to see how the program was, let's say, further developed in this part. So did I find a more illustrative image here? We have the 6510 Commodore 64, while here we have the 6502 VIXI 20. Note this IRQ, which is relatively line 4, while here in the Commodore 64 with the 6502 IRQ, it is line 3. So, as I was saying, we will work on this type of image of signal, because then when the 6502 or 6510 receive, so to speak, a signal on this pinout, here, so to speak, they generate what is an internet. So to speak, they drop what they are doing in very simple terms to perform other things. Also note what I was telling you about the internet not maskable and so on, in which these clearly cannot be masked. Obviously, before continuing, we need to go to what is the Commodore 64. I have already loaded the program. Apparently nothing happens here because for the simple reason that in my program, I told it that if everything is 0, you must execute your normal routines that you have to do. But if I, in a certain location, otherwise, I put you 1, 2, 3, 4, 5. Up to a certain number, you must go and execute that routine that I want, or one or more routines. So in this case, we do Pocket 251.01, where in this case, I have this particular location that the scheduler will go to check. I tell it to execute what is routine number 1, and you see that while routine number 1 is being executed, I am still free to do other things. And it does nothing else but at intervals. Let's say at regular intervals to go and modify what is the border of the screen, and you see that here it is clearly interrupted. I can still use what is the routine, the blinking character on the screen, and here 2 I can turn it off. But what happens in this routine? We will go and see. Basically, if I do 3, then I expect that not only is there the blinking character, but there's also the coloring of the screen border. And how is this done? In what way? First, by executing the routine, subroutine, and then executing subroutine 2. Obviously, here I can turn everything off and then return to normal. Now let's go see how this scheduler was made. So we had already talked about this part, of course. Here are some process addresses that I want to talk about first, because in the process address I made a table. You see here I have my subroutines up to 8, but more could be made. Then of course, since it's not a speed of millions and millions of megahertz, you also need to write subroutines that can be executed within a certain time. Anyway, subroutine 1, as you have seen, it increments the screen border. Subroutine 2 or others increment the character, the 3.3. It increments what is the subroutine 3 increments the flashing character and so on. Obviously, everything here still needs to be adjusted. It's a draft. What it does, the most important part is here in the scheduler, as you can see. And it could also be expanded in the sense that each process could have a priority and make it more complex, but that's not our case because it's just a little bit for fun. What does it do? Here, a table of masks is set up. that does nothing but manage the numbers from 1 to 8, or rather from 0 to 7 in reference to our subroutines. I have also prepared a table of what are the low-high addresses, so low and high regarding the subroutines P, because with a direct jump, as you can see, then I directly take what is the routine here. Obviously, the extra RTS is useless, and then it does nothing but continue the execution normally of the program after the interrupt has occurred. Obviously, you also need to be careful, especially with this instruction, because there are certain types of conditions where you should return with layout 81, but we won't look at that here. How does the scheduler work? It incrementally increases the process counter each time and checks through our allocation if it matches. So if it's 1, 2, 3, and in fact simply a kind of callback, and through the number that it loaded into the mask, so 1, 2, 4, 16, 32, 64, 128, it does nothing more than load the address into the table. Obviously, it is stored in what is the process address, but here I seem to recall that it is one of those temporary zones that are not used. We could also place a location in page 0. Obviously, if, as I mentioned before, since an end is done, this results in 0, then our subroutine is not called directly, but instead, so to speak, the normal execution is called. Of the Commodore 64, and indeed, as you can see here, the entire execution, let's say, is reset and absolutely nothing is done. Whereas before, practically, in an alternating manner, you could, let's say, see the screen or something else first. Obviously here I have created several subroutines, but they are all the same because it was just to demonstrate the actual practicality of this solution. Of course, there are also 8 subroutines, but here they all do the same things, though they can easily be modified later. You can also add more subroutines. You can create what is certainly a more complex, more substantial scheduler. You can also make a scheduler that takes into account, as I mentioned, the priority of the processes, or assign more execution time. In short, it is truly an art. Then programming in a multitasking system. Well, what can I say? Let's say that's all. We had fun bringing a part of multitasking to our beloved Commodore 64. And why not also to our beloved VIC-20 and other Commodore machines. If you like it, comment. If you find the video useful, subscribe to the channel. Maybe we could come back with an even more complex scheduler and let's say with other features, perhaps taking the raster into account and particular conditions of the raster and so on. I wish you a good continuation. See you again on the Project CD Chronicles channel. Thank you all for staying with me up to this point. See you, Claudio.